Recently, very important researches have emerged about gravitational waves and baby star sneezes. The first research with us says, gravitational waves reveal first-of-its-kind merger between neutron star and mystery object. Astronomers announced on April 5 that they may have detected a collision between a neutron star and a lightweight mystery object. An object larger than the largest known neutron star, but smaller than the smallest known black hole. The finding sheds light on objects that exist in this murky realm, which was long thought to be empty but in recent times has revealed otherwise. More specifically, a signal detected in a pocket of the universe roughly 650 million light-years from Earth indicates a rare merger between a neutron star and what astronomers suspect is a surprisingly lightweight black hole. The pair would have danced around one another and merged about 650 million years ago, generating ripples in the fabric of space and time known as gravitational waves. These waves were sensed and flagged on May 29, 2023, by a network of antennas in Japan, Italy, and the USA. The black hole candidate, which is about 2.5 to 4.5 times heavier than our Sun, is heavier than the established limit of 2.5 suns for a neutron star, but lighter than the lightest known black hole, which weighs about 5 solar masses. This places the newfound object within the mass gap, a mysterious region that separates the heaviest neutron stars from the lightest black holes. Black holes, small and big, are born from the violent deaths of immensely massive stars. A few models of how stars evolve, however, predict black holes with masses within the mass gap range cannot directly form from such stellar deaths. As for the latest finding, astronomers say they cannot pinpoint just where in the sky the mammoth objects merged, because only one LVK detector was recording data when the signal was detected. Nevertheless, the finding has raised hopes that there may be many more such mass gap objects out there waiting to be discovered.
The second research with us says, baby star sneezes tell astronomers a lot about their development. Every new parent knows the cold anxiety that grips them when their baby sneezes for the first time. That's when a litany of possible issues and ailments probably begin to irrationally race through your mind. Researchers now know baby stars also sneeze, but these infinitely more powerful postnatal sneezes launch gas, dust, and magnetic energy. In other words, they're more useful to the cosmos than stressful. These eruptions from cold protostars are actually a vital part of stellar development, and can tell scientists a great deal about that stellar body's evolution and maybe even if it will one day be surrounded by planets. Imagine a baby sneezing and their parents knowing from this they will one day be an architect. The stellar sneezes were discovered by a team of scientists from Kyushu University in Japan who used the Atacama Large Millimeter, Submillimeter Array to study the disks of gas and dust that surround infant stars that collapse to birth planets. These disks are called protostellar disks. The scientists also discovered other spikes extending out thousands of times the distance between Earth and the Sun from the protostellar disk. They interested these as evidence of stellar sneezes that had previously erupted from infant stars within MC27. The team hopes the scientific community will use its findings to better understand the intricate processes at play when stars are born. Similar spike-like structures have been observed in other young stars, and it's becoming a more common astronomical discovery.
The last research with us says, monster star gains magnetic personality following stellar merger. Massive stars gain their magnetism by colliding and merging with other stars. According to evidence from a bizarre binary system surrounded by a dusty, element-rich nebula. Inside that bipolar nebula is the star system HD 148937. Located some 3,800 light-years away, in the southern hemisphere constellation of Norma. HD 148937 contains two massive stars in orbit around one another. One of these stars is magnetic and, in fact, is the brightest and hottest massive star known to have a magnetic field. That's puzzling because, based on what we know about the interiors of stars, massive stars should not have magnetic fields. We're used to thinking of the Sun as a magnetic star, which drives phenomena such as sunspots, flares, prominences, and the solar wind. The magnetic dynamo is generated inside the Sun, at the boundary between the inner radiative layer and the outer convection layer. In the radiative layer, energy is transported from the star's core via gamma-ray photons at the convective layer. This energy is converted into current of hot plasma that rises up to the sun's visible surface, where the energy is released as light and heat. The less massive a star is, the greater proportion of its volume the convective layer takes up. The smallest red dwarfs are nearly entirely convective, and are very magnetically active as a result. The more massive a star, however, the smaller the convective layer is. This means the most massive stars are entirely radiative, and without a convective layer, they cannot generate a magnetic field. Yet, somehow, about 7% of the most massive stars have been observed to possess a magnetic field. The question that has perplexed astronomers is how? The answer to this secret may lie within HD 148937. After studying HD 148937 more closely, using 9 years' worth of observations from the ESO's Very Large Telescope Interferometer, which combines the powers of 4 8-meter telescopes in Chile. After a detailed analysis, we could determine that the more massive star appears much younger than its companion. Which doesn't make any sense since they should have formed at the same time. The more massive of the two stars, with between 50 and 60 times the mass of the Sun, is the magnetic one. Based on its temperature, it appears 1.5 million years younger than its companion. This is a significant age difference for massive stars, which typically only live for a few million years before going supernova. There's also the nebula to consider. Its bipolar shape is indicative of its origin in some kind of outburst from one of the stars of HD 148937 within just the past 7,500 years. The nebula contains high concentrations of carbon, nitrogen, and oxygen, which are elements typically found inside stars, but not outside them. The observations were able to piece together this particular stellar jigsaw. One star in a binary system being younger than its companion is a sure sign that a merger of two stars has taken place in the past few thousand years. Thank you very much for watching. Goodbye.